Hello my dear children of class 11 science. Today I again welcome you all through this mode of teaching, that is YouTube mode, and in today's class also we do continue with the chapter that is surface tension. Okay, and we will complete this chapter today. Okay, because there are few numericals that I want to solve, okay, based on the capillarity, the topic that you learned in the last class. Okay, so after that we go to the next chapter and the next unit. Okay, we'll start new unit, that is unit number 8. Okay, now one of the first problem that I'm going to solve based on capillarity is based on capillarity, and the problem number 1 says that a liquid rises to a height. So any liquid which rises to a height of 7.0 centimeter in a capillary tube, and that tube has a radius 0.1 millimeter, a very small radius of capillary tube. Okay, now the density of the liquid is 0.8 into 10 power 3 kg per meter cube. So the liquid which we are using and that the liquid which rises in the tube has a density 0.8 into 10 power 3 kg per meter cube. The question says that if the angle of contact between the liquid and the surface of the tube is 0, that means a very small angle, and that is almost 0. Means the angle of contact between the liquid and the surface of the tube is how much? 0 degree. Means 0 degree. Then calculate the surface tension of the liquid. So we need to calculate the surface tension of the liquid. And in this question, we take the value of G, the acceleration due to gravity is 10 meter per second square. So in order to solve this problem, so let me just highlight what is given in the question. Okay. Now the liquid rises to a height 7.0 centimeter means the height, and height is expressed by symbol h. And how much? 7.0 centimeter. The 7.0 centimeter means 7 only. Okay, but I convert this centimeter into meter, and you know what you need to do? You have to multiply by 10 to minus 2 meter. So what is the height in which the liquid rises in the capillary tube? 7 into 10 minus 2 meter. Okay, now that tube has a radius. The radius of tube is basically marked by letter R, small letter R. And what is the radius of the tube? 0.1 millimeter. But I change this millimeter again into SI unit, that is meter. So what we need to do? We multiply by 10 to the minus 3. So children, converting millimeter to meter means you have to multiply by 10 to the minus 3. Okay, so 0.1 into 10 to the minus 3 meter. Now the density of the liquid is given by symbol rho. Rho is the symbol of density of liquid. And how much is the density? 0.8 into 10 power 3 kg per meter cube. This is the density of liquid. Okay. Now question says that if the angle of contact between the liquid and the surface of the tube is 0 degree, 0 means 0 degree, that means theta is how much? 0 degree. If theta is 0 degree, then we can calculate the surface tension of the liquid. The surface tension is basically marked by letter what? T. So I am marking surface tension by capital T. But for information, surface tension can be even symbolized by letter S, capital letter S also. Okay, so I am representing by capital T. So capital T be the what? Surface tension. This is the surface tension of the liquid. Now to calculate the surface tension, okay, and even your value G is also given, that is 10 meter per second square. So we use the formula to determine the height. Okay, and there is a formula we have learned already. Okay, and that formula determines the surface tension, and the formula actually written that T equals to H R rho G by 2 cos theta. Now in case of capillarity, this is for capillary tube. This is for what tube? Capillary tube. Children, for capillary tube, the formula of surface tension, okay, can be easily calculated by using formula that is T equals to H R rho G by 2 cos theta, where theta, as I said, is the angle of contact. Okay, so let's substitute the value and calculate the surface tension. Okay, H, the height, how much? 7 into 10 to the minus 2. The radius 0.1 into 10 to the minus what? 3. Or density of liquid is 0.8 into 10 to the power 3, sorry, and the value of G is also given, that is 10. Okay, whole divided by 2 into cos 0 degree. And children, you know what is 0 degree? Cos 0 degree value 1. Okay, so let's substitute the value. Now before I substitute the value, let me just cancel this. 2 1s are 2, 2 4s are 8, means 0.4. So this is 7 into 0.1. Let me multiply 0.7. See, I multiply this 2, 0.7, and there is 0.4 into 10 power. Now see, exponent 10 to the power minus 2, 10 to the minus 3. Okay, 10 to the minus 2, 10 to the minus 3 means 10 to the minus 5 into 10 power. Now this 10 only means power how much? 1. So 3 plus 1 is 4, so 10 to the power 4. Okay, whole divided by cos 0 degree value is what? 1. Okay, now we can further simplify. Now it will be 0.7 into 0.4 into 10 to the power minus 4, minus 5 plus 4 means minus 1. Okay, now you can remove the decimal. Now it is 7 into 4, sorry, by how many 0? 2 0 means 100 in the denominator into 10 to the power minus 1. Okay, now 7 4s are 28 into 10 to the power minus 1. Now 100 means 10 to the power 2, and that 10 to the power 2 I'll take from denominator to numerator is 10 to the power minus 2. Okay, so the value can be written as 28 into 10 to the power minus 3, because minus 1 minus 2 means minus 3. So T, the surface tension of liquid, is 28 into power minus 3 in Newton per meter. We can leave this way also, but basically the answer which we write is in single digit. This is in 10 digit. Now we write the answer in unit digits. Okay, so what I do, when there is negative power and when you put one number front decimal like 2.8, so 28 can be written as 2.8, then your power decreases by 1. So 2.8 into 10 minus 2 Newton per meter. So finally look at, see the answer of surface tension of liquid, that is T equals to 2.8 into 10 minus 2 Newton per meter. Okay, so this is one of the simple numerical based on capillarity. Now we solve problem number 2. Okay, now this problem is also similar like problem number 1 only. Okay, now in this question, problem number 2, it says that the diameter of a capillary tube is 0.4 into 10 to the power minus 3 meter. So let me start directly with the solution of this question. Okay, so capillary tube diameter is given. So let me just write down diameter of what tube? Capillary tube. Okay, diameter of capillary tube is how much? 0.4 into 10 to the power minus 3 meter. So when diameter is given, then we calculate what? Radius. So radius is half the diameter. So first I calculate what? Radius. The radius, which is marked by letter R, and radius is half of this diameter, means 0.4 divided by 2 into 10 to the power minus 3 meter. Now the power remains same, 10 minus 3 only, but 0.4 divided by 2 means how much? 0.2 into 10 to the power minus 3, and the unit is meter. So what is R out here is the radius of the tube, that is 0.2 into 10 minus 3 meter. Now the tube is held vertically. Now it is very important how you keep the tube in a liquid. So in this particular problem we are keeping the tube, okay, vertically, means it is held vertically in a liquid, okay, whose density is given. So density of liquid is marked by letter rho, and the density is 0.8 into 10 to the power 3 kg per meter cube. Okay, and the liquid surface tension is also given. Surface tension of liquid means T, and that is 9.8 into 10 to the power minus 2 Newton per meter. This is the surface tension of the liquid. Now what actually you need to calculate out here? Determine the height to which the liquid will rise in the tube. Means height we need to calculate. So let me just assume out here that H be the height of what? Liquid. Okay, be the height of liquid rises in the what tube? Capillary tube. Capillary what? Tube. Okay. Now for this particular question, angle of contact is given, that is 0 degree. So theta, as you know, 0 degree. Theta 0 degree means nothing but it is the angle of what? Contact. between the tube surface and the liquid, okay, which is contact with the tube, okay. And in this particular question, the liquid is exerted by the gravity. The value of gravity is not given, acceleration of gravity, but we take how much? 9.8 meter per second square. This is the value of acceleration of gravity, okay. Now to calculate the height, so let me start with this formula again. As you know, the formula you have learned already is surface tension T equals to what? H R rho g by what? 2 cos theta. So surface tension of the liquid is given by H R rho g by 2 cos theta. This is for tube placed vertically on a liquid. This is for capillary tube. Today this is important to note it down. So this is for capillary tube, okay, held vertically. Held what? Vertically. This is held vertically on the liquid, okay. Now if T equals to H R rho g by 2 cos theta, then I'll make H as the subject. So H equals to 2T cos theta by, now this R rho g will go in the denominator. R rho g will go in the denominator, okay. Now let's substitute the value. 2 into T, here surface tension how much? 9.8 into 10 to the power how much? Minus 2 into cos theta means 0 degree. Again we are taking angle of contact 0 degree. R, the radius that we have calculated, 0.2 into 10 to the power minus 3. Density of a liquid how much? 0.8 into 10 to the power 3, and the value of G is 9.8. Okay, so let's do cancellation out here. 9.8 cancel out. 2 1s are 2, 2 1s are 2 means but 0.1 cancel out. So in the numerator is 10 to the minus 2. Cos 0 degree is 1 by, this is 0.1 into 0.8 in the denominator. Now see, 10 to the minus 3, 10 to the power 3 means cancel out, minus 3 plus 3 cancel out, is simply 10 to the power 0. And you know any base with power 0 means 1. So let me just do right this way, 10 to the minus 2 by 0.1 into 0.8. If you multiply it is 0.08. Okay, 0.1 into 0.8, if you multiply 0.08, because 10 to the power 0 means 1. This is 10 to the power 0 means 1. Now, if there is no number, consider 1 in the numerator. So children, I will take this 10 to the minus 2 in the numerator only. But 1, if you divide with 0.08, you get 12.5. So 1, if you divide by 0.08 with the help of calculator, it will come 12.5 into 10 to the power minus 2, and the unit is meter. Okay. So you can leave the answer, the height is 12.5 into minus 2 meter. But I write the same answer in more compact form, changing this 10 to the power minus 2 meter as 1 centimeter. Children, 1 centimeter is also equivalent to 10 minus 2 meter. Okay. So finally the height will be 12.5 centimeter. Yes. That means up to what height the liquid rises in the capillary tube? When that tube is held vertically inside the tube, that is 12.5 centimeter. So this capillary rise, or I mean the liquid which rises in the capillary tube, is also due to what tension? The surface tension of the what? Liquid. So H equals to 12.5 centimeter, and it is due to the surface tension of liquid, and also due to the what? The tube, the size of the tube also. Okay. So this is problem number 2. Now I will be solving one more numerical, the last numerical problem from capillarity, and with that numerical problem, we complete this chapter, that is surface tension, and that we do in the next YouTube video.